We're going to cover some analytical geometry in this section. So areas, we're going to calculate areas in analytical geometry, areas of triangles and quadrilaterals. There's your thought for the day. Alright, so area of a triangle. If one side of a triangle is parallel to either coordinate axes, the length of the side and the length of the altitude of that side can be found readily. Then the formula 1/2 base times height can be used. If no side of a triangle is parallel to either axis, then either the triangle can be enclosed in a rectangle whose sides are parallel to the axes, as you can see in the figure 12-26, or trapezoids whose bases are parallel to the y-axis can be formed by dropping perpendiculars to the x-axis, as in figure 12-27. Right? You can see we've got the trapezoids. We've got this trapezoid and this trapezoid, right? And then we could draw this line, and then we have a third trapezoid that we could subtract. So the area of a triangle can be found from the areas in the figures so formed. In figure 12-26, the area of triangle ABC so ABC, its area can be found by subtracting, taking the area of the rectangle and then subtracting the areas of these three triangles. Right? That would give me the area of the unshaded region in the inside. Or if we use a trapezoid, I could find the area of this trapezoid, and I could find the area of this trapezoid, right? Find the area of the two trapezoids, and then we could subtract the area of this trapezoid, right? Make sense? Alright, let's do some examples. Find the area of a triangle whose vertices are 1, 2, 7, 2, and 5, 4. Alright? So here the triangle is parallel to the base and height are parallel to the x-axis and the y-axis. So my base, okay, what is my base going to equal? Without, just using the numbers, what would my base equal? Shatis.
6.
And how'd you get that?
Because since it's a straight line, since it has the same y value, you could just subtract the bigger x value minus the
right.
little x value.
That's correct. Yes, 7 minus 1 equals 6. We took this value minus that value, and we got 6. The height, what would the height be? Julia, what would the height be?
2.
Yeah, it'd be 4 minus 2. 4 minus 2 equals 2. So then the area equals 1/2 base times height, which equals 1/2 6 times 2. So, if the triangle, which equals 6. So if the triangle is parallel, the base and height are parallel to the x and y axes, it's pretty straightforward. When it gets more complicated is if we have a triangle with no side parallel to an axis. So we have to find the area of the triangle with the given vertices using the rectangle method and using the trapezoid method. Let's do the rectangle method first. So with the rectangle method, we're going to take the area of ABC we're going to take the area of the rectangle DEFC, and we're going to subtract the area of these three triangles. All right, from the rectangle, we subtract their area. All right, so we would have we have to find some different areas. We've got the area of DEFC. That's the rectangle. Rectangle's area is base times height, so it would be, okay, what's my base and height of this rectangle? Nina? Yeah, it's actually a square. 6 times 6, so that equals to 36. Then we have to find the area of, let's try to find the area of triangle DAC. There, triangle DAC equals, the formula is 1/2 base times height, so that equals 1/2. What am I going to use for my base, Jordan? 6. What am I going to use for my height, Madeline? DAC. Triangle DAC. 2 times 2, that's going to be 6. Then we've got triangle ABE, which is also 1/2 base times height, so that's going to equal 1/2. So ABE, what can I use as my base? Abby? What?
3.
Okay, we can use 3. And for my height, what can I use? Ahicha? 4. So that's going to be equal to 6, right? And then we have to do triangle BCF. That equals to 1/2 base times height, which is equal to 1/2. And then the base, what's my base? Zach?
6.
Yeah, 1/2, 6. What would my height be? Lily?
3.
3. So that's going to be equal to 9, right? So then the area total is going to equal to my original rectangle, 36, minus 6, minus 6, minus 9, which is equal to 15 units squared. All right, any questions on doing the rectangle method? No questions. Okay? Let's do the trapezoid method. So with the trapezoid method, again, I take the area of a trapezoid ABGH. Let's outline that in blue. ABGH. We take that area, and we also take the area of BCJH. I have those two. I take their area, and then I subtract the area of the lower trapezoid. We subtract this area from that, and what I'm left is with the area of triangle ABC. Alright? Okay. So let's clear that out so that you can see better. Alright. So we've got the area of trapezoid, the area of the trapezoid ABHG is equal to 1/2 base 1 plus base 2 times the height, right? So that's going to equal to 1/2 of, what's base 1 going to be? Nina? 4. What's base 2 going to be? Alyssa? ABHG? 8. 4 plus 8. What's the height going to be, Chris? 3. Right? So that's going to equal to 18. Then we do the area of BCJH. It equals to 1/2 base 1 plus base 2 times the height. So that's going to equal to 1/2. What's one base for that, Nick? 8. What's another base? Ben?
2.
2. Height is what? Shelby? BHJC. 3. Right? So that's going to equal to 10 to 30 divided 1/2 of 30 is 15. So that one's 15. Then we do the trapezoid with whose bases are 90 degrees from the other bases, right? It's turned on its side. So the trapezoid ACJG is equal to 1/2 base 1 plus base 2 times the height. So that's going to equal to 1/2 of, what's my base going to be for ACJG? Let's see, Lexi Nash. Okay, one of the bases is 2. What's another base? Emma? 4. And what's my height going to be? Carmen? 6. Good. All right, so that's going to equal to 18. Right? So now, I've got those values. Make sure everybody's got those written down. I look at this formula up above, right? We're going to plug into that. So my area total is going to equal to 18 plus 15 minus 18, which is equal to 15 units squared. All right? Now, any questions on using trapezoid method? Now, on the homework, you have 3 that you're going to do with the rectangle method, and 2 with the trapezoid method. The ones on the homework are a little bit different in that you have to, so you're going to plot your points on your grid. You have to use 4 trapezoids. Okay, you'll have to use 4. You have 3 across, and then you'll subtract 1. I think I'll let you guys figure that out. But I'll give you the clue that you have to use 4 trapezoids rather than 3 on the problems that I gave you. So make a note of that, or just remember, on the trapezoid problems, use 4 trapezoids rather than 3. Any questions on analytical geometry?